Okay, so I'm Bailey.
And I'm Serena, and we're in Miskarski's physics class. Today we're going to be talking about Newton's 3 laws of motion.
3 laws. Okay, so before we do any of this,
we're going to go through what we've used in this, what we're going to be using, and just like stuff like that. So practically, as you can see, we're going to be using balloons. We have a lot of them. We're going to be using some acrylic paint and this garbage can. This acrylic paint is 59 milliliters, but for this video we needed to convert it to kilograms.
okay,
and so we could
use it in our calculation.
Yeah.
And here we have our conversion. Okay, so in our conversion, we have the 59 milliliters, and we have 59 milliliters, and we need to convert it to kilograms. So we need to put there's 1,000 milliliters in 1 kilogram. So we put the 1,000 milliliters on the bottom, and those units cancel, and so we end up with 0.059 kilograms, and this is what this weighs. So,
yeah,
and see that.
So to go on to the 3 laws of motion.
Okay, so Newton's first law. An object at rest is going to remain at rest, and an object at motion is going to remain at motion unless acted upon by an unbalanced force. And this is often called Newton's law of inertia, and we'll show you why.
So practically, even though this thing is at rest, the paint, there's forces acting upon it right now.
Okay, so in order for this to be at rest, we have the weight force, which is the same as gravity, that's pushing down on the container. And it's labeled FW for weight force. And then we also have the natural force, which is pushing up against the bottom of the container. And this force and the weight force are both equal. So that's why it's at rest and it's not moving, because it's equal forces. And so the natural force is labeled Fn.
So this thing will stay there until something acts upon it, which I just did. Which that would be considered the final force. I am the unbalanced force acting upon the paint, and it will stay in motion until it hits the floor, which was also considered an unbalanced force because it stops the motion of the paint. Also, for if there wasn't like sides to this paint thing or a cap, if the cap was open, the paint would just spill everywhere because the unbalanced force would not like affect the paint inside it, only the outside of the bottle.
So that's why it's called Newton's law of inertia, is because that's what it's called. When you have inertia, you're moving forward. And that's the same concept if you've ever been in a car accident or you've seen the driver's training videos. Your car stops, let's say you hit a tree, your car is going and it has a certain amount of inertia, and then it stops, your car stops, but you don't stop with your car unless you're wearing a seatbelt.
Because that unbalanced force doesn't affect you because you're in the car.
And that's why they have things like seatbelts and airbags to keep us
from like not going through a windshield.
So that is a real life application to Newton's first law.
So to go on to Newton's second law, this is probably his most famous one. It's force equals mass times acceleration.
FMA.
That's like an actual thing too. Like,
people are crazy. There's t-shirts, there's banners, there's everything.
So practically, if we want to figure out what kind of force we need to move this paint bottle, we would have to calculate that with the F equals ma. So that's exactly what we did here. So in the beginning of the video, we told you that the mass of this paint is 0.059 kilograms. So to figure out the force, we know that the acceleration is gravity, which is 9.8 meters per second. To do that, we just times those two together, and we got the force of 0.5782. So that's what kind of force we need to be able to exert on this bottle to make it move.
And we're going to need a force that's greater than that to make this actually go off of rest, because it can't be a balanced force, so it can't be the same amount of force. It's going to need to be an unbalanced force, which is going to take more.
We got some balloons here we're going to test out to see if it works. So this is a pretty small balloon.
Not a lot of mass.
And it doesn't really...
Didn't even budge.
And then here's a medium-sized balloon. It doesn't even do anything. We got this elongated balloon. It kind of not really moves it. So we got this big balloon, and it was able to move the bottle.
And that's because that this
Has
balloon,
the greatest amount of mass compared to the smallest amount.
if you take the smallest balloon and the biggest balloon, you can see that this one contains less air, which is meaning less mass for this balloon. Therefore, it wasn't able to push this over.
So heavier objects require more force to move the same distance as the lighter objects.
And that would be Newton's second law of motion. Okay, so moving on to his third law. For every action, there is an equal and opposite reaction. And for every force, there is a reaction force that's equal in size but opposite in direction. And to show this...
Well, kind of like you guys just saw that balloon pop.
Yeah.
There was more force that was on the outside than the inside, and that caused the balloon to pop. Which was kind of scary. So practically, we got this balloon right here. We're both, like, exerting 100 newtons right now, say. And so forces come in pairs, making that equal. But say I'm exerting 300 newtons.
And I'm only exerting 50.
Then I will overpower her. And then say if she...
Vice versa.
if I'm only exerting 30...
And I'm exerting 200.
The balloon will go this way.
So in order to move the other force, you need to have a larger force. That's kind of like if you watch boxing or fist fights, the person who has more force is going to be the one to overpower the other one. It's the same kind of concept.
Yeah. So
in a nutshell,
so his first law is objects at rest tend to stay at rest.
And objects in motion will tend to stay in motion until acted upon by an unbalanced force, which could be the floor or you knocking it off the table.
And then Newton's second law was force equals mass times acceleration.
And this is Newton's most famous law, remember. And so what you do is you take the mass of the object and you multiply it by the acceleration, which is gravity. And then you end up with the amount of force that you're going to need to take your object and push it out of rest.
Yeah, and you can use this equation is very easy. Like if you don't have the mass, but you have the force and the acceleration, you can always figure that out. As long as you have at least two of the variables, you'll be able to figure it out.
And then the third law, which in a nutshell is that forces come in pairs. Gotta remember that. That was kind of like another example of that is the weight force and the natural force are pushing up against each other. These are two force pairs. So they equal each other out, which is making this stay at rest. And I mean, right now, even just sitting on the floor, we're exerting a force on the floor, and the floor is exerting a force on us. So there's another force pair.
If the forces were unbalanced, like if there was more force coming off the ground, this thing would be like hovering right now.
That's kind of how it is like in space because there's no gravity, so there's nothing to keep you on the ground. So it has to be, the forces are equal in size, but they're in opposite directions. So like we showed with the balloon thing, if it's not equal in size, then it's going to push one way or the other.
Yeah, causing like a balloon to pop or something.
Like you just saw in this video.
Anyways, I hope you guys had fun learning with us.
Yay! So those are Newton's 3 laws of motion. Education!
Yay!
Woo!
Ow. Yay!